Hello there everyone, this is Sheila Harlangyao and now I'm going to discuss about different network media used for computer networking. Network media is the actual path over which an electrical signal travels as it moves from one component to another. This information sheet describes the common types of network media, including twisted pair cable, coaxial cable, fiber optic cable, and wireless. There will be the type of network media, the twisted pair cable. Twisted pair cable is a type of cabling that is used for telephone communications and most modern Ethernet networks. It comprises of two separate insulated copper wires, which are twisted together and run in parallel. The copper wires are typically 1 mm in diameter. One of the wires is used to transmit data and the others is the ground reference. Two types of twisted pair cable. First is the UTP cable or the unshielded twisted pair cable. UTP cable is used a variety of networks. Each of 8 individual copper wires in UTP is covered by an insulating material. Also, the wires in each pair are twisted around each other. It is also has a 100 OHM copper cable that consists of 2 to 1,800 unshielded twisted pairs surrounded by an outer jacket. They have no metallic shield. This makes the cable small in diameter, but unprotected against electrical interference. The twist helps to improve its immunity to electrical noise and EMI. UTP advantages. UTP has an external diameter of approximately 0.43 cm or 0.17 inches. Its small size can be advantageous during installation. UTP also easy to install and expensive. UTP cable is easy to install and is less expensive than other types of networking media. In fact, UTP costs less per meter than any other type of LAN cabling. UTP also is most adaptive wiring technology, and because UTP can be used with most of the major networking architectures, it continues to grow in popularity. The disadvantages also are involved in using twisted pair cabling. However, UTP cable is more prone to electrical noise and interference than other types of networking media. The distance between signal boosts is shorter for UTP than it is for coaxial and fiber optic cables. The following summarizes the features of UTP cable. The speed and throughput is 10 to 10,000 Mbps. The average cost per node, less expensive. The media and connector size, small. Maximum cable length is 100 m short. The second type of twisted pair cable is the shielded twisted pair or the STP. Cable combines the techniques of shielding, cancellation, and wire twisting. Each pair of wires is wrapped in a metallic foil. The 4 pairs of wires then are wrapped in one overall metallic braid or foil, usually 150 OHM cable. As specified for use in Ethernet network installation, STP reduces electrical noise both within the cable, pair-to-pair coupling or crosstalk, and from outside the cable or the EMI and RFI. STP usually is installed with STP data connector, which is created specially for the STP cable. However, STP cabling also can use the same RJ connectors that UTP uses. Although STP prevents interference better than UTP, it is more expensive and difficult to install. In addition, the metallic shielding must be grounded at both ends. If it is improperly grounded, the shield acts like an antenna and picks up unwanted signals. Because of its cost and difficulty with termination, STP is rarely used in Ethernet networks. STP is primarily used in Europe. The following summarizes the features of STP cable. Speed and throughput is 10 to 100 Mbps. The average cost per node moderately expensive. Media and connector size medium to large. The maximum cable length is 100 m short. When comparing UTP and STP, keep the following points in mind. The speed of both types of cable is usually satisfactory for local area distances. These are the least expensive media for data communication. UTP is less expensive than STP. Because most buildings are already wired with UTP, many transmission standards are adapted to use it. To avoid costly rewiring with an alternative cable type. The second type of network media, coaxial cable. Coaxial cable consists of a hollow outer cylindrical conductor that surrounds a single inner wire made of two conducting elements. One of these elements, located in the center of the cable, is a copper conductor. Surrounding the copper conductor is a layer of flexible insulation. Over this insulating material is a woven copper braid or metallic foil that acts both as the second wire in the circuit and as a shielded for the inner conductor. This second layer or shield can help reduce the amount of outside interference. Covering the shield is the cable jacket. The following summarizes the feature of coaxial cables. Speed and throughput 10 to 100 Mbps. The average cost per node inexpensive. Media and connector size is medium. The maximum cable length is 500 m medium. The third type of network media, the fiber optic cable. Fiber optic cable used for networking consists of two fibers encased in separate sheets. If you were viewing it in a cross-section, you would see that each optical fiber is surrounded by layers of protective buffer material, usually a plastic shield, then a plastic such as Kevlar, and finally an outer jacket. The outer jacket provides protection for the entire cable, while the plastic conforms to appropriate fire and building codes. The Kevlar furnishes additional cushioning and protection for the fragile, hair-thin glass fibers, wherever buried fiber optic cables are required by codes. A stainless steel wire sometimes is included for added strength. The two types of fiber optic cable. Single mode. Single mode fiber cable allows only one mode or wavelength of light to propagate through the fiber. It is capable of higher bandwidth and greater distances than multi-mode, and it is often used for campus backbones. These types of fiber uses lasers as the light generating method. Single-mode cable is much more expensive than multi-mode cable. Its maximum cable length is more than 10 km or 32808.4 feet. The multi-mode fiber cable allows multiple modes of light to propagate through the fiber. It is often used for workgroup applications and intra-building applications such as risers. It uses light-imitating diodes or LEDs as a light-generating device. The maximum cable length is 2 km or 6561.7 feet. The following list briefly describes two of the commonly used connectors. First is the EC. EC type connectors feature a push-pull connect and disconnect method. To make a connection, the connector is simply pushed into the receptacle. To disconnect, the connector is simply pulled out. Next is the ST. ST fiber optic connector is a bayonet type of connector. The connector is fully inserted into the receptacle and is then twisted in a clockwise direction to lock it into place. The following summarizes the features of fiber optic cables. Speed and throughput, more than 1 Gbps. The average cost per node, expensive. Media and connector size is small. Maximum cable length is more than 10 km for single mode up to 2 km for multi-mode. The last network media is the wireless communication. Wireless communication uses radio frequencies or the RF or infrared or IR waves to transmit data between devices on a LAN. For wireless LANs, a key component is the wireless hub or access point used for signal distribution. And that's all for my reflection about the different types of network media used for computer networking. Thank you for watching.